management team in Linaro. And I'm working with everything that isn't related to CPU and scheduling stuff, but still related to power management. So what we've been doing here in this field is that together with Linaro, a member engineer from Qualcomm, and with Kevin Hillman, a former Linaro employee, but nowadays with Bay Libre, we more or less together has been working on this CPU cluster thing. And so this is just session is about giving you a brief update on where we are right now, and also give you a quick background, because we have more or less run this kind of session at earlier connects. So. Okay, so let's get started. Yeah, I will start out with some background, and then we'll go more deeper into in the design a little bit, and then I will give you an update on where we are right now. Again, please just interact, ask questions whenever you want. So yeah, we have these kind of complex SoCs nowadays, and it's not getting easier. The complexity is increasing, and yeah, topology is becoming more and more complex. So we have all these kind of different devices and CPUs and GPUs and whatnot, and which we want to do some kind of idle management of, to be able to save power when we don't have anything useful to do. And if we go closer to CPUs and look into what's quite closely connected to these, yeah, you more or less find this kind of stuff around them. There is like, yeah, domains and coherency and caches and yeah, a lot of stuff that's closely coupled with the CPU. And when you want to deal with idle management of these kind of topologies, yeah, you have to take all these kind of things into account, and then it's becoming it's becoming really complex. So we have obviously found out that this is an issue for these kind of complex topologies, and the current method to fix this is to use the CPU idle framework. But yeah, it doesn't really scale when you get into these complex SoCs. So we need something else, and so what we have been working on is that for everything else but CPUs, we are using runtime PM framework together with the generic power domain, and that is kind of a proven method nowadays. It's being used quite a lot. So it's a method that works for everything else but CPUs. So we thought it made sense to look into if we could kind of reuse that for CPUs as well. So that is more or less what we've been exploring for a while now and been working on. And yeah, so that's actually what this is all about on our work. So this little picture here is trying to describe more from a diagram point of view of how it looks today without our CPU cluster solution, CPU PM cluster solution. So we'll see that the cluster and the coherence domain is more or less platform vendor specific hacks. That's never reaches mainline, or if they do reach its mainline, it's bundled inside the CPU idle driver somehow of that particular SoC. And we think it should look something like this instead. I don't know if you can read those small text there, but the point is that we want to deploy runtime PM support in the idle path more or less, or when to use this reference count of the runtime PM to be able to manage the domain around the CPUs, more or less, and to be able to model the topology of the SoC. We make use of the infrastructure that the generic power domain provides. So we have a CPU PM domain implementation that is more or less a user of the already available infrastructure from the generic power domain. And to that CPU PM domain, which is a very generic piece of code as well, we have an ARM64 PSCI implementation, which is what we have started out with, and that is the platform driver here. Questions so far? So yeah, as I said, we are being focused on an ARM64 platform. It's actually the Qualcomm 410C 96 board that we've been using, and it's the thing that is very important from this is that to be able to get this work, we need a PCI firmware that supports the OS initiated mode, and we're also using this composite state ID from the PCI spec to be able to manage the domain around the CPUs, in the cluster around the CPUs. And for an ARM64 SoC, the only thing that you need to add to enable your platform would be to just add some description in the device tree, and then everything is supposed to work, at least. So we have actually tried out this for another vendor as well, the MediaTek, what's it called, a Val board from MediaTek that we've been using in the power management team. So it's just a DTB patch that is needed to enable yet another platform. So we will be very interesting to talk to you about enabling more vendor SoCs to widen tests that we can do and see if there are some corner cases perhaps that we haven't thought about. So please come and talk to us if you want to try out this for your SoCs. We will have actually a hacking session tomorrow afternoon. Is it? What time is it? 2:30. 2:30, yeah.
It's available in the schedule.
Yeah. So if you want to go come and discuss this with us, I'd be happy to help. All right. Some quick update on what we've been doing so far. As I said, we have been exploring about the runtime PM and generic power domain for CPUs. And to be able to reuse these kind of frameworks, we have seen that, we have been, generic power domain has been going through an evolution of changes. And some of those changes might not be directly related to the work we do in the CPU cluster thing, but some is and so forth. So I've been trying to list those that is recently related to this work. So we have the DT bindings for these domain idle states, and we're able to pass these bindings from the generic power domain. So that is recently merged. I don't really know exactly if it was 4.9 or maybe 4.8, I don't know. Then the other thing that was recently merged was the IRQ safe domain support in generic power domain, which is explicitly needed for CPUs when they are used in this context. And so, yep.
What means merge and
Yeah, that's a good question. Actually, in the last version of the series, which was we had a discussion about the DT bindings in Linux plumbers. That's, yeah, in this autumn. We realized that we wanted to change the DT bindings in a way that we wanted to get one domain encapsulated per CPU. So one CPU will be within one domain. So that actually changed the execution path in the generic power domain for how it powers off the domain. And so this review stuff there is those final pieces that we needed to fix. But actually it should say merged or maybe queued because it's in Raphael's next tree.
I have a question.
Yes, please.
What about the ACPI status? What about the power management through the ACPI method?
ACPI?
Yeah. I saw you. This shows the method is device tree.
I don't really understand the question.
There's no definition of the power domain in ACPI.
No. There is no relationship to. I mean, there's no corresponding thing in the ACPI. Is that your question? Why? Why there isn't, or?
No, are you planning to have this available for CPI?
Ah, okay, sorry. No, this is not going to be ACPI applicable. So
We can't do a port. We can't apply that to ACPI in the next future.
we could discuss and see what we need to do in that field. Absolutely, yes. But yeah, there's more work needed to enable that support. Absolutely, and definitely there is a lot of work that can be reused from this work, of course.
Okay, thank you.
Do you need for that? You're working on enabling PM domain and runtime PM with the CPI. That's another activity you have. You need this before being able to port that, or?
I think I think this can go on in parallel because the ACPI isn't being managed by the generic power domain. It's a different implementation of power domains. So I don't think there is a problem in proceeding both in parallel. Okay. And the stuff that hasn't been merged or queued yet has been actually recently posted by Lina. I think it's just a couple of days ago when she posted a new respin series. So and all the series has been posted earlier, so it's a review that is ongoing. So hopefully we will get some pieces within the next release cycle, and those that doesn't get in will respin what's needed. So yeah, it's a work in progress on the final pieces. I can't really give you a guaranteed estimate when we're done in this, but it's going quite well, I would say. We don't have a specific target to get everything in. We want to do that as quick as possible, of course. But for every release cycle, we'll get something in. And now we have all the infrastructure pieces is there now. Now it's more the CPU cluster specific things that is missing. And we're also looking into some improvements or some next steps, what we would like to do. And one of those things is to try to deploy this approach for an ARM32 SoC. And that is going to be a little bit more complex, of course, because we have this fragmented solution of how to idle CPUs on domains. Of course, it's SoC specifics. Yeah. So, but the idea with deploying it for an ARM32 SoC is to. I think there's two good things we could get out of that, and one of the things is that we will have some kind of consolidation, perhaps, and we can get some parts of the CPU idle framework. Yeah, maybe we do some consolidation on that field. Perhaps if you look into the coupled idle state, for example, we might be able to have one generic solution for that and hook in the SoC specific bits into that. The other thing is, of course, to find new corner cases, which would benefit ARM64 solutions as well. Another thing that we have been looking into is we've been monitoring the work Daniel is doing on the IRQ prediction work. Currently, we're using just the next wake-up timer event when we want to distinguish the next the idle state that we want to enter. And if we would make use of this IRQ prediction, we see that this could also be an improvement for this. But it's quite easy to switch to this later on. We also see that there is a little bit of locking overheads of this new of this one-time PM and PD framework, and we will look into those, see if we can do some optimizations on that. We've already been doing some kind of optimizations, but we might be able to do more on that field. So that's something that we is thinking of looking into as well. And the final thing is that we have these CPU PM notifications that we know that people want to get rid of, and yeah, hopefully when we get this in place, we might be able to remove those and replace those with one-time PM callbacks instead. But that's the next step, I would say. All right. I don't have more than that, and as I said earlier, we have a hacking session tomorrow. So, any more questions?
Which kind of advantage do you see using OS initiated compared to coordinated mode in PCI? Right now, everything is done in the PCI, in the secure world. Using OS initiated mode, though, the rich OS will choose the state of each CPU. Which kind of advantage we will get? I have some idea, but I'm interested to get.
So I guess this is more like a PCI question in general. So, yeah, if we can do all these kind of calculation and measurements and predictions on the rich OS side, I imagine that we can get better power. We get better power solution. We waste less power. If we would have, comparing to if we would have given this kind of, if the PCI firm would have done this by themselves, because then it more or less would have to guess about all this stuff.
And do you expect more connection between you and the scheduler, for example, to get one side that can be, let's say, put? I mean, because the decision is done in your framework, so
yes.
you can get much more connection to other services in the kernel, get more information instead of.
Yeah, I mean that's the whole idea. That we should get a good, we should get the information from good data.
Do you expect to tie the cluster idling stuff information directly inside the scheduler, so the scheduler can say, okay, this group is idle when it's taking scheduling decisions, so you get this group is idle. So I won't wake it up.
That is not, we haven't thought about that. That might be some,
Because in this case, you have all the locking mechanism. How do you deal with the locking mechanism per CPU with the cluster? Do you delegate that to the PSCI to take care of that?
yes.
So
We only give, we only
in this
give,
case is
we only care about the reference counting, more or less,
okay.
to make sure that if the cluster is in use, and if not, then allow it to go into an idle state.
It could be interesting to give back information to the scheduler about the CPUs and tie that with the schedule.
From the real state. Maybe one advantage that you should be a bit aware of the real state of your cluster compared to coordinated mode. Because at the end in coordinated mode you don't know, you are just vote for the state of the CPU or the cluster, but the firmware will have the final decision. Whereas now it's up to the read choice to select the final state.
Yes. So that's
Very
So my question comes back to what you said, is that definitely true then? Because so runtime PM has done its reference counting and decided that we can enter a cluster idle state. So then you make your PSCI call with this what's the word? The state parameter that says bus asleep.
Yeah.
But there's still another level of validation that has to happen, right? Because there's the locking in the PSCI implementation. So you still might not enter the cluster state.
exactly.
In that case, does the rich OS find out that it's been refused? Okay, so do you get a return from the PSCI call that says, oh, in this case we didn't enter the state because something in opted is happening? So can you know for sure?
But are you talking about the platform coordinated mode now, or talking about the OS initiated?
OS initiated?
So there is no, I mean, you don't vote on the CPU in that. You just tell the CPU what to do.
But surely something could be happening in a secure world so that the
Yeah, you mean the actual PCI call
yes,
returns
after
file?
you
Yeah.
do the PSCI call, you're still not guaranteed to be able to enter the state.
No, no.
No. At now, how OT is working, schedule only if the read OS asks him to do something. So normally,
So you're saying by the time you made the PSCI call, you can guarantee that you're able to enter the state?
yeah. Or maybe if you have to sleep. No, because yeah, it's synchronous. I'm not sure.
Could there be an interruption immediately following the call or something?
The point is that all the call to the opti is started from the read choice side. So you know when you have something ready, so you can take the decision. You have all the information. Right now, nothing can just be generated by the OT by itself, as far as I can tell. So if you don't have any pending requests, then that you should not prevent you.
Any other questions?
I'm curious, one question that just now you mentioned PSCI OSI mode, right? So this needs the ARM trusted firmware to support this mode.
Yes.
Okay, so this has been enabled. We need to enable in the ARM trusted firmware for this firstly.
So how we implemented this in the
Yeah.
yeah, since we are collaborating with a Qualcomm member engineer, she has taken care of that part. So to get a new firmware update, which support this, and that is the same case for in the MediaTek case with our assignee in our power management team, Freedom, has been helping out with that part. So yeah, that is something that you need to take care of if you have decided to use the platform coordinated mode instead. That's going to require a firmware change. Okay. right. Thank you very much.